No, toy room. I'll send him down in a minute.
Okay, hold on. You there again, Linda?
Yes.
Sorry. Okay.
Oh.
So what number are you up to?
We're still on 8.
Because this is 68%. In the middle is 68%. And then this part and this part. So this whole thing fills up 100%, correct? Yeah. So 68%. So 68% would be within one deviation of the mean. Oh, that might be it. He's thinking it's 68% because that's the first. Because your deviation is in the middle, right, of the 68%.
Are we looking at that bell curve? Are we looking at the chart?
Up above.
Okay.
So
We're looking at the 68, 95, 99.7 chart. You know how you have the empirical rule? And so your mean is in the middle of the 68%.
oh.
So one standard deviation, my husband is thinking, what percentage of the data from a bell-shaped distribution will be within one standard deviation? So 60, he's thinking it's 68% because that's where your mean falls.
Yeah.
Right in the middle of that. Or is it 32? Is it half of 68? Because you're going over one either side. So is it 68? He thinks it's 68.
Because it's either side of the center,
I think it might
which would total to 68.
He said, I think the area sheet 68.
It says, yeah. So the area in the middle is 68, but it says here what percentage of the data will be within one standard deviation of the mean.
So let's talk about the mean.
So 68.
And we have 30.
I think so.
It's 68.
So, okay, so let's try 68 on our quiz and see what happens.
Okay.
Okay, so 9.
I'm writing all these down too, so.
Awesome.
Okay, so 9. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question, and I have that up.
Okay.
What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If the answer was 0.389184, your answer would be 0.389. Okay. So
Between -1 and 1.
So the area is 0.3173.
So did you put the z-score, or did you put 1 and -1 in your z-score box? And then we fill in the middle section because we want to know the data in between.
Yeah, so this is where I get lost. This is where I'm like, huh, what?
Okay, so we want to find the area in between those two. So what I did was fill in only the blue area in between, and I got 0.6827. Or it would be 0.683 if you round because it's 3 decimals.
So you put the numbers in, or you didn't put numbers in, you just did the area?
I filled in the bottom where it says z-score to 1 because that's telling us in the question that's the z-score. And then we want the middle, right? It says, what is the proportion between -1 and 1? So when you look at the applet, the area in between is all you highlight. You don't highlight the ends because it doesn't care about that. It only wants the middle data. So the area is at the top, and it should give you a number. When my number is 0.6827. This confused me for a little while too, until I started watching the video, and then it kind of clicked.
And that's what I need to do. I didn't have time to watch the video yesterday.
We have more questions we're going to get to, and it'll say, what's the area above the z-score of 1? So then we would only highlight what's above the z-score. So we wouldn't highlight the middle. We would only highlight that right-hand section. If it's
And then that
below,
would give us the z-score at the top.
the z-score is on the bottom in the boxes. And then
Oh, okay.
the answer should be that box that says area.
Okay.
Oh, got it. Got it. I totally understand what you're saying now.
Yeah.
Got it.
So if it's, okay.
Okay. So then the next one is suppose the z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? So negative
So it's the same
2,
thing? Yeah. Just put 2 in instead of 1.
and it's 0.9545. So it's
Yeah.
0.955 because you're rounding, right?
Yeah. Yep. 3 decimals. This is question 10.
Yeah.
How did I get a different answer there? I got the right answer this time. 955. Right?
Yeah. And then,
So you put a 2 in the box at the bottom?
yeah. And then,
Okay.
and then the next one is 0.977. Is that what?
0.99. Hold on.
0.997. 997. I'm sorry, 997.
You got 99. Is it?
For the next one, it's -3 and 3.
Yeah. So 0.997.
Is that what you got?
Yep.
Look carefully at your answers. What do you observe? The values match the
Am I
60.
losing you?
No, I hear you. Do you hear me?
Oh, no, I didn't hear what you just said.
Look carefully for number 12. Look carefully at your answers to the last. Let me make sure I still have Linda there. I don't have like you up. I just have you.
Okay.
I have my screen up. Look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 97.7% rule. As the z-score increases, the area between the -z and the z decreases. The probability double as you move from z1 to z2.
I think they match the value.
Yeah, it matches the values match the
68.
rule.
So my husband is, when we were talking, he's like, okay, so we answered that other question correct, number 8, because we answered that question as we were doing the other ones. So if you look at what we just did, the 68% is correct for number 8.
Oh, right. I see that now.
Okay. 13. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. Sorry, I'm totally reading weird. G to P of kilogram to the -1 of times D to the -1. The population mean protein requirement for adults is 0.65 gram of protein times kilogram to the -1 times D to the -1, and the population standard deviation is, and I'll just let us read that one, what proportion of the population have a protein requirement that is less than that calculation? Give your answer as a decimal accurate to 3 decimal places.
Okay, so what I did for this one, and I think I did it right. Do either of you know how to do this?
I
No.
do not know how to do this part.
Okay, so what I thought we needed to do was find the z-score. So we do that by taking the population, which is the 0.60. Wait, population mean protein requirements points. Hold on. Oh no, it's 0.65. I'm sorry.
Yeah.
It's fine.
So, what is the mean?
The mean is,
0.5.
yeah, 0.65.
Okay, so the data is the 0.60, right?
The population standard deviation is 0.07 grams.
Okay, I'm sorry. So yeah, so the proportion of the population of a protein requirement that is less than 0.60. So we're going to
So
take
that's
that 0.60 minus the mean, which is 0.65, divided by the deviation, which is 0.07, and that will give us our z-score. So if I did my numbers right, it'll be negative 0.71428. And then we plug that into our applet. And when we plug that into our applet, we want to find out which is less. So when we put the z-score in of negative 0.71428, we want to go less, which is going to be on the left-hand side. And when I looked at that, it was 23.76%. Again, if I did all of this right.
So what was the answer there? I kind of got lost a little.
So my answer was 23.76%. I'm putting it back in again just to make sure I did it right.
23.76%,
Mm-hmm.
which is 0.237, because we have to
Right.
do it in a decimal.
Yeah, so do we round the 7 to an 8?
Yeah.
It's 0.2376, so it would be 0.3237,238. And we don't need to write it as a percentage. We need to write it in there as a decimal.
Right.
Okay, so do you understand how I did that?
Yes and no, because you're telling me and not showing me.
I know.
I'm a visual. Like if you were on the computer screen
Oh,
and like
my.
kind of showed me, it'd be so much better.
So you know
That's
how
why
to
in class would be so much better because the professor would be doing it in front of us.
Yeah. So yeah, you were just
So-
talking really fast.
I wrote all
I
the
know how to
steps
find
down.
it. You were just going through it super, super fast.
Okay, so if you know how to find the z-score, or do I need to go over that?
Just say it one more time because I was writing it down, but you
Okay.
went really super fast.
Okay, so to find a z-score, what I did was write the formula on top of my paper.
Yeah, because
So
I have that in my notes. I just have to find it in my notes.
Okay, so it's the population of whatever we're looking for. So in this instance, the population that we're referencing is in the question, which is 0.60.
Yeah.
We're going to take that number and subtract it by the mean, which we find out in the data is 0.65.
Yeah.
Then we're going to divide that answer by the deviation of 0.07.
Yes.
So when you do that, you should get negative 0.71428, and then it just keeps going and going, and I didn't add all the numbers.
Yes.
So then that number is the number, the z-score. So when you go to your applet, you're going to plug that in the bottom where it says z-score.
And so for the next one, we just plug in the 0.70 instead of the 0.60.
Mm-hmm. I
Okay.
didn't get to the next one yet.
Yeah.
So then when you plug in that z-score number, because we want the data less than the z-score, we're only shading in the left-hand area because that's going to be less. And then that number box that says area, that's our percentage, which is 0.2376. Kind of
Yes.
like what we did with the other numbers, but we were doing the middle.
Yeah,
The
exactly.
data less. Do you understand, or did I go too fast?
Nope, I got it.
Okay.
I mean, I haven't heard from Linda. Let me, oh, yep, she's right there.
Yeah, I understood.
She's
Thank
being
you
really
for going
quiet.
over that. Because I'm writing down as you're going.
Yep.
So
0.70.
the next question is the same information. We just, instead of going less, we're going more. So we're only highlighting the stuff on the right. So we need to unhighlight the stuff on the left. But it's actually the same number. Yeah. So 14 is the same answer as 13.
Oh, exact same answer?
Because it should be the same proportion on either side because it's a normal distribution.
Whether you're highlighting on the left of it or on the right of it.
You're only highlighting on the right for this one because we want.
Oh, because it's a 0.5 difference just on the other side.
Exactly.
So it's 0.238. Got it.
Okay. A proportion. Oh, this is a completely different number. So we have to do our deviation for 15 or the z-score.
So we're on 15 now, right?
Yep. So 13 and 14 are the same answer.
Okay.
But 15 has a different z-score.
Mhm.
Yeah, and I'm on 15 right now.
So for 15, we're going to take that population, which is the 0.70 minus,
0.60.
which is 0.65, divided by our deviation, 0.07.
0.65.
I did.
Oh, I subtracted it wrong. So 0.70 minus. Oops. Point. And then divided by
0.07. And I got another long, huge number.
I got 0.714286.
Mm-hmm. Yep. So
Okay.
that's our z-score. Now we need to put it into our thing.
And where I put that at the top of the applet for the area,
No.
Or where do I-
That's the area.
that's our z-score
Z-score, which goes in the bottom.
on the bottom right.
It's the same z-score as the other one. Are you seeing that too?
Yeah.
Oh, it is.
It's
How does
only
that
off by
happen?
a point. I mean, instead of 0.6, it's 0.7. Is less than, so it would be the 0.238 again. Let me just check and see, but because we're going to only highlight the stuff on the left.
So how come it doesn't change if the population changes?
Huh.
Did you get a different thing, Linda, or no? Did you get the
No, I got the same. I'm just wondering why it didn't change if the number of the population changed.
Well, no, unless I did my math wrong in the one before. Did you do the math on the 0.60, anyone?
Yeah, let me double
Yes.
check that
It
math.
was the same as the number 13.
0.60
I mean, I'm driving in a car, so.
minus
bump the
0.65.
road.
Let me
Unless we carry it
try
out at
that again.
0.714.
Same answer.
28571.
Negative. Oh, is this one positive though? Well, it doesn't matter.
Oh, it's positive.
71428.
But even if it's positive,
It's going to be the same because you're going to have the negative on one side and the positive on the other side. So.
Right.
0.28.
Unless
Yeah.
we need to wrap up the 0.714285 whatever to 0.71. It said not to round till the end, so it's the same.
Huh.
Yeah, that's weird.
Maybe it doesn't make that big of a difference with that small of a difference in numbers.
So
Maybe
fine.
that's what it's trying to tell us.
So 0.238.
8.
Okay, let's try that again.
Makes sense. You're still got the same deviation.
My husband says it makes sense a little bit.
Okay, as long as it makes sense to
I wish I
somebody.
had a husband that was good at math. My husband's in sales. He just has to be good at talking.
Oh, I hate this one.
Find the probability that a randomly selected person will have protein requirements at its between points.
Okay, this should be fairly easy though. But
Remember
now I
to
gotta-
find the probability.
Okay, so we have to, let me look. We have to find the z-scores of both of them, which we know.
Which
And
is,
then we have to subtract them. And if we do that, we get 0. Hold on, I have to look up my notes for this. Do either of you know what to do with this one?
no, I didn't get this far in the notes because
Just reading what it
I
says,
didn't
the
get
hint
this far down.
that we subtract the larger side from the smaller side.
Which so far would be 0, wouldn't it?
It would, because our answers were the same.
Yeah, this is where,
Oh gosh.
let me look. I still have my homework stuff up though. I have my book up.
Oh, here we go. Hold on. Z-score. Okay, so you find the 2 z-scores, which we know are exactly the same. And then you subtract them,
Find the probability
That's the
between two values.
probability between them. So it's 0 because they're both the same z-scores.
Yeah.
Yeah, that's what it
I could
appears.
be wrong, but according to my notes here, that's how I did it. I found both z-scores, and then I took both of my z-scores and subtracted them from one another to find the difference between them. And then that was the probability between those 2 original numbers.
And then here we are doing the percentile of the distribution.
So what does the question ask for?
It wants to find the, here we go.
35th percentile.
35th percentile. Let me look in the notes here.
It just wants to know the probability that a random selected observation will lie between the 2 values. So it should be, I think, 16 is 0. Are you on 17?
Yes.
Oh, sorry, my bad. Okay. I'm still caught up on the other one.
So I don't know how to do this one.
Find a 35th percentile for the protein requirements for adults. And looking in the notes, calculating percentiles for a normal distribution. Value percentiles for normal distribution, z-score by plugging in the z-score. So this one you put in the z-score, and in the area you put in like, so okay.
So in the area you put in the percentage, so it will be 0.35, correct? And it wants to know. So we just want to know the middle part. So we need to highlight only the middle.
0.35.
0.35.
So it'd be
Where do you put the 0.35?
at the top.
Okay.
So then it would be, see, this is
It would be the 0.454.
oh, let me, what z-score did you put in? Think
Well,
that,
okay, when you put in the percentage in the area, it gives you a z-score. And I think we're going backwards. So we're trying to find the z-score.
let me take out the z-score then.
Because we are assigned the 35th percentile, so it's telling us our percentile for the protein requirement for adults.
It's not letting me take out my z-score.
I might be off here, but that's what I'm thinking.
But it doesn't have to be some sort of z-score in there?
But when you put in the 35, it gives you a Z-score.
It will compute that Z-score for you.
Put in our Z-score that we had before. Let me look. I could be wrong. 0.238.
Oh, point.
It's going to change our area up top.
Well, that's what I'm saying. 0.238 was our.
Right? Or is that the percentage? Do you have any idea?
Kelsey, if you put the 0.35 in the top square,
I think the
does
zero's
it allow
off.
you to do that?
I'm putting in 0.35 and it's giving me something really weird.
Does it give you an equation?
Yeah.
Yeah.
It's not letting me take out a Z-score. Let me look at the notes. Click on the areas until the positive Z-scores are shaded blue.
Oh. Okay. So, let me pull this up.
Lost her again. Just waiting to see if Kelsey comes back.
Equals, I got 0.68178.
So you got 0.68
178.
sorry, 0.68
178.
for 17.
Mm-hmm. Because we have the z-score, we found that out, of 0.454. So when you put it into the equation, that's our z-score, which equals x, because we don't know what x is, minus the 0.65, which is the mean, divided by 0.07, which is the deviation. So I multiplied 0.07 by each side of the equation to get rid of the 0.07 on the denominator. And then when I multiplied 0.07 on the one side times 0.454, then I added the okay, I didn't write down what I got there. But then I need to add the 0.65 away from the x, so the x is by itself.
I wish you could see our faces right now.
So if you can do that mathematical equation, then, because you need to take the 0.07 away, right, from the x side, because we don't want that in the denominator. So you're
Right.
going to multiply that to the other side of the equation, which is the z-score, which is 0.454. So I can do that, so that way you guys are like walking, So 0.07 times 0.454 is 0.03178. And that's going to equal x minus 0.65. But we have to get rid of that 0.65. So we're going to add it, because it's a negative, to the 0.3178. Do you understand?
Yeah.
That I understand.
Darn it. Okay. So when you do that, it should come out to 0.68178. And that's what the question is asking us for.
Which actually is 0.682 if you round.
Mm-hmm. Does that make sense or no?
Yes.
You understand how I did that or not really?
Yes, in a very roundabout way.
Because it's giving us a percentile, but we
I
don't
just-
know the z-score.
And like I understand this to a point, but unless I see it, Jennifer, I'm not gonna understand it. Does that make
That's
sense?
why you need to watch that video. Now, I will tell you, I don't know who did the video, but he does make a few mistakes. So if you do the math along with him, you're like, what? That doesn't add up. But then there's a little box that pops up on the screen that will give you like the corrected, information. But it was really helpful to help me understand what I needed to look for.
Yeah, I'm just so behind because of that migraine yesterday.
Yeah. So we only have one more question.
Yeah. So the 80th percentile.
So this is going to be the same thing that I just did. But instead of the 0.35, we're going to go to 0.80 in the area box. And then that gives us a z-score of 1.282. Hold on, I just thought of something. Yeah, okay, never mind. And that's our z-score. So we're going to do 0.80 equals x, because we don't know what that is, minus 0.65 divided by 0.07. You understand that, right?
Yeah, I have
Yeah.
that equation written out.
Okay, so then we just have to solve the equation. test and I did this all wrong, then I'm so sorry.
Well, it won't be any different than if I did it. Okay.
Where do we put the z-score in that equation?
So when you go to the applet,
No, in that equation, the 0.80 equals x minus 0.65 over 0.07, where does the z-score go in that equation? Or it doesn't go in there yet?
the point, oh, I'm sorry. The 80 is not the z-score. It's 1.282 is the z-score.
Okay, so it's 1.282 equals x minus
Yeah.
0.65 over, okay.
Sorry. Because
So then we
that's-
times each side by the 0.07.
Yeah. So it would be 1.282 multiply 1.282 times 0.07. So that would be 0.0919. I'll just say equals x minus 0.65. We have to add the 0.65 to the other side. So plus 0.65. So I got, or x equals 0.7419. So we're going 3 decimals, so it would be 7.742.
So 0.742?
Mm-hmm.
Okay.
I love my pen.
All right. So I'm going to submit this.
4.2. Don't hate me if I'm all wrong.
No. We have a,
I was up till till midnight trying to figure this out last night in the hotel.
oh, bless your heart.
So we got
How's the house
the
hunting?
last 1, 2, 3. We got the last 5 wrong. So it's those, we got 14 through 18 wrong.
Great. 4, 5, 6, 7. So then maybe I don't know.
Let me see something.
What numbers did you? Hold on.
Or did you get them right?
Well, that's what I'm wondering right now. 13. Yeah, 14
Oh no,
is wrong.
14, 15, 16, 17, and 18. Let me see.
Did we round wrong?
No, the numbers we came up with, we rounded, right?